Hello students, welcome back to my YouTube channel Data Shah. I have started a new playlist, Probability Distributions, in which I have taken two lectures related to random variables, so discrete random variable and continuous random variable. In this particular lecture, I'll be talking about the questions on continuous random variable. So let us discuss certain questions which are very important from the exam point of view. So consider the first question. The life in hours of a certain kind of a radio tube has probability function fx, which is defined as 100 upon x square, where x is greater than equal to 100 and it is 0 when we are having x strictly less than 100. Now we need to check certain paths. Find the distribution function. Second, find the probability that life of the tube is 150 hours. Third part, find the probability that the life of tube is more than 150 hours. So let us see what we need to do in this particular question. So when we are talking about the distribution function means we are talking about CDF. So what we mean by a CDF? So let's consider the formula for CDF. So in the solution, of the first part, the distribution function is defined by capital Fx, which is by the definition minus infinity to x fx dx. Now we need to find capital Fx. It would be some f1x for x strictly less than 100, and we have an f2x that would be x greater than equal to 100. Now, in this case, we need to find out what is f1x and f2x. So separately, we'll be finding out. So consider the case when, x is less than 100. So the probability of x less than 100 would be from minus infinity to x fx dx by the definition of CDF. So using 1, we get this. Now, what is this? From minus infinity to x, x is less than 100. So when we are talking about less than 100, we know that the function value is 0. So automatically, this would become 0. Now, when we are talking about p of x greater than equal to 100, then then this would be equal to minus infinity to x fx dx. But here I'll be talking about minus infinity to 100 fx dx plus 100 to x fx dx. Now minus infinity to 100 fx dx is 0 as we know. So this becomes 0. From 100 to x integral, we'll be having fx as 100 upon x square dx, which is equal to, solving this, integrating 1 upon x square, I'll get the answer as 1 upon x upon minus 1. So from 100 to x, that means I am getting this as 1 upon x minus 1 upon 100. So solving this, I am getting the value as 1 minus 100 upon x. So thus the CDF, the distribution function, is given by capital Fx, which is 0 when x is less than 100, and it is 1 minus 100 upon x when we could say x is greater than equal to 100 and less than infinity. So this is what we have. Now, in the second part of the question, it is given, find the probability that the life of the tube is 150 hours. So we need to find the probability of x equal to 150 hours. Now, if I'll consider this to be the second equation, so in this, using 2, we get P of x equal to 150 is nothing but f of 150, which means this is 1 minus 100 upon 150. So that's so 1 minus 2 upon 3 is nothing but 1 upon 3. And the last part that we have is find the value of the probability that the life of the tube, that is capital X, is more than, greater than 150 hours. So again, to find this, I'll be using the distribution function, but let us see how can I write this. We know that P of x greater than 150 is the complement of P of x less than equals to 150. Now, by definition of CDF, P of x less than equals to 150 is nothing but f of 150. So again, using the above thing, we can calculate it and I can get the answer here. So this would be 1 minus 1 upon 3, that is 2 upon 3. So we have already calculated f of 1 upon f of 150 in the second part. So using second, we can write here. So this is very easy. With the distribution function, we can easily find out the answer. So let us consider another question in which we'll be finding the CDF of a function. So let us consider here the probability density function of a random variable x if f of x is Now find the probability of x greater than equal to 1.5. And in the second part, you need to find the distribution function. So I'll just write CDF. That is fx we need to find. So in this, the fx, that is the PDF probability density function, is given to us. So we could easily find the value of first part, that is the probability of x greater than equal to 1.5. So that this would be equal to 1.5 to infinity. So the limits of the integral would be 1.5 to infinity fx dx. Now using the first equation, I can split this from 1.5 to 2 and then 2 to infinity. So as we know, from 2 to infinity, it is 0. And from 1.5 to 2, it is 2 minus x. So I'll just substitute the values here. So we get this as 2x minus x square upon 2 from 1.5 to 2 plus 0. After calculating, I will get here this would be 1.75. So the final answer that I'm getting is this. So the first part was very easy. The tricky part is the second part that we need to find out, that is the CDF. Now, when we are finding the CDF, remember in the last question, similar part we'll be doing here. So you need to find out capital Fx, which would be f1x from minus infinity to the first breakpoint, that is 0. Then f2x 0 to 1. f3x from 1 to 2. And f4x from 2 to infinity. This is what you need to find. Now, how will we find this? On the similar pattern, what we have discussed in the previous questions, we'll consider the case where in the first case, when x is less than 0, so when x is lying between minus infinity to 0. So in this particular case, the p of x less than equals to x, that means our fx, our f1x, I would say, would be, which is 0, using the first equation, what is given to us. Now, when we consider the second case, when x is lying between 0 to 1, so here we'll be talking about the f2x, which is p of x less than equals to 1. So this would be equal to minus infinity to x, fx dx, but we can break it into the two integrals, that is minus infinity to 0 plus 0 to x. So as we know, minus infinity to 0 is just 0. 0 to x is the fx. Fx is given to us as x using again 1. So let me just show you. As we could see, from 0 to x, that means x greater than 0, the value given to us as x of fx. So I'll just substitute here. So I will get here the final answer as x square upon 2. So this is my f2x. Now, the next case, when x is lying between 1 to 2, so f3x would be p of x less than equals to 2. So by definition, now we'll be splitting this as minus infinity to 0, then 0 to 1, and lastly, it would be 1 to x fx dx. So putting all the values, minus infinity to 0 is 0, 0 to 1 is x, and 1 to x is 2 minus x. Again using 1. So this is just put the values. So let us check. We'll get our this as x square upon 2. So this would be half minus 0 plus 2 times x minus 1 minus half x square minus 1. So this cancels. Half plus half is 1, 1 minus 1. So we are just left with, sorry, this is 2x minus, this would be 2x minus x squared upon 2, and 1 minus 2 is minus 1. So this is our f3x. Now when x is greater than 2 but less than infinity, so in this case that means we are discussing f4x, p of x less than equal to infinity. So that would be from minus infinity to x. Now splitting it as minus infinity to 0, 0 to 1. Next would be from 1 to 2. And last would be from 2 to x fx dx. So putting the values, this is 0 as we know. This would be 0 to 1 x dx, 1 to 2 minus x dx. Again, this is 0. So on calculating this, the final answer that we'll be getting would be 1. So thus the CDF that we are getting here, the fx would be 0. In the next, we are getting it as x square upon 2 from 0 to 1. As we have calculated here, x square upon 2 is f2x. Then f3x is this. So 2x minus x square on 2 minus 1 And lastly, we have 1 from 2 to infinity. Otherwise, also we can write. So this is how we can solve the question related to CDF. So thank you so much, and we'll meet in the next lecture.